Welcome to the introductory video on Principles of Electronic Communication in third semester for Diploma in Electronics and Communication Engineering. Communication is the process of exchanging information. All electronic communication systems have a transmitter, a communication channel or medium and a receiver. In electronic communication systems, the message is referred to as information or an intelligence signal. This message in the form of an electronic signal is fed to the transmitter, which then transmits the message over the communication channel. The transmitter itself is a collection of electronic components and circuits designed to convert the electrical signal to a signal suitable for transmission over a given communication medium. Transmitters are made up of oscillators, amplifiers, tuned circuits and filters, modulators, frequency mixers, frequency synthesizers and other circuits. The communication channel is the medium by which the electrical signal is sent from one place to another. Many different types of media are used in communication systems, including wire conductors, fiber optic cables and free space. Along the way, the noise is added in the communication channel and in the receiver. Noise is the general term applied to any phenomenon that degrades or interferes with the transmitted information. The message is picked up by the receiver. A receiver is a collection of electronic components and circuits that accepts the transmitted message from the channel and converts it back to a form understandable by humans. Receivers contain amplifiers, oscillators, mixers, tuned circuits and filters, and a demodulator or detector that recovers the original intelligence signal from the modulated carrier. In this course, we will explore the various modulation techniques such as analog modulation, pulse analog modulation, pulse code modulation and delta modulation, digital modulation and spread spectrum modulation. Week 1, Week 2 and Week 3, the lectures will be on analog modulation techniques such as amplitude modulation and frequency modulation. The topics covered are concepts of frequency translation, amplitude modulation, description of full AM, DSBSC, SSB and VSB in time and frequency domains, method of generation, demodulation, description of FM signal in time and frequency domains. Week 4 and Week 5, the sessions will be on pulse analog modulation. The topics covered in Week 4 and Week 5 are ideal sampling, sampling theorem, aliasing, interpolation, natural and flat top sampling in time and frequency domains. Week 6 and Week 7 are on PCM and delta modulation systems. The topics covered in Week 6 and Week 7 are uniform and non-uniform quantization, PCM and delta modulation, signal to quantization noise ratio in PCM and delta modulation. Week 7, Week 8 and Week 9 are on digital modulation. The topics covered are baseband transmission, line coding, RZ and NRZ coding, intersymbol interference, ISI, pulse shaping, Nyquist criterion for distortion free baseband transmission, raised cosine spectrum, passband transmission, geometric interpretation of signals orthogonalization. Week 10, Week 11 and Week 12 lectures are on spread spectrum modulation. The topics covered are introduction, pseudo noise sequences, direct sequence spread spectrum DSSS with coherent BPSK, processing gain, probability of error, frequency of spread spectrum FHSS, application of spread spectrum CDMA. Thanks for joining us in this introductory video on principles of electronic communication. In upcoming videos, we will dive deeper into the principles of electronic communication. Please do join us for more insights. Happy learning.